Okay, so today we're going to do confidence intervals with means, or even a mean difference. I don't think we're getting to that yet, but we're just going to get into some. This is the first part of lesson 7a, mostly checking the conditions, talking about degrees of freedom. So when you're talking about means, so instead of doing a normal curve, we're going to do what's called a t-curve, so a t-distribution. So it's similar kind of to a normal distribution. It's symmetric, it's single peaked, it's bell shaped. It's centered at 0 for the t curve, right? Just like a z curve is centered at 0. But it has this new thing called degrees of freedom, and that makes a big difference in the shape of this. It has more areas in the tails than the standard normal distribution. So it's best to see a picture of that, but the tails are fatter when you see it. So here's actually a good picture. So the purple-ish color is the normal curve. The red one there is smaller degrees of freedom, maybe 2 or something, I'm not sure. Yeah, 2. So you can see that the red curve has a lot of area in the tails, kind of fatter tails there on the ends. You can see it's taller. As the degrees of freedom increases, the graph becomes more and more normal. So when degrees of freedom is 9, you can see it's starting to look more normal, but it's not quite there yet. But if t got really big, it would start looking practically normal. But we use the t-curve. It's a better estimate when using means. So instead of, so you notice we've been calling the 1 prop z interval, 2 prop z interval, 1 prop z test, 2 prop z test. Interval proportions are always z curves, so the normal curve. With means, typically, I think always, they're going to be the t-curve. So we use a slightly different curve when we use that. So we can find the t-critical value for 99% with 3 degrees of freedom. So the way we do that, let's kind of draw it out, kind of like we have in the past. So if we have I guess it's not a normal curve, a t-curve here. I'm not going to put, actually I'm going to draw it kind of like we have in the past. So for 99% cup, so 0.99, we're trying to find this t star here rather than just a z star. So you have to figure out there's 0.005 over here and 0.005 over here. So remember the command used to be called inverse norm. So now it's called inverse t. And the number you're going to put in there is the area that's to the left of this. So all but 0.005, so 0.995, comma, you have to put another number. So that's the area, that's correct. But you see where it says 3 degrees of freedom? So the degrees of freedom for this type, for basic mean, is going to be the, well, they just told us degrees of freedom in this case. We'll get a formula in just a minute, I guess. Let's wait on that. So comma 3. So let's see where you can find this command. It's got to be in there somewhere, right? So if you go menu, distributions, statistics, oops, sorry, menu 6, distributions is number 5, and there's TCDF, kind of like norm CDF, and then there's something called inverse T, kind of like inverse normal. So T is kind of like our normal curve for, it's not a normal curve, it's a T curve for means. So area is 0.995, degrees of freedom told us it's 3, and we just type it in and we get our inverse T amount is 5.84. Okay, they did it slightly different. They did 0.005. They found the one on the left and made it positive, but I like the way we did it. Okay, so now we need a formula for this. I don't think they told us there. No, they haven't told us yet. Okay. So similar thing, we're going to draw the t-curve. Oh, so I like to do it this way for finding t critical value. So 0.95 is here. So half of 5%, so 2.5%, so 0.025 over here. So we're finding this value right here. And so we're going to use our calculator. And so because n is 12, and that's not degrees of freedom. Degrees of freedom for this type is going to be n minus 1. So 12 minus 1, which is 11. So let's try this. So let's go back to that command menu, 6, I think it was 5. Inverse t, area is 0.995, no, 0.975, sorry, for this one. And degrees of freedom is 11, not 12 there. And that'll give you the 2.2. That's your t critical value, 2.200, so that's good enough. Degrees of freedom is n minus 1 there, so 2.201. 90% confidence, so again, you want to get good at like doing this. So 98 or 90% means there's 5% over here, right? So we've got the inverse t, 0.95, comma, 48, so it would be 47 would be your degrees of freedom there. So that should start looking somewhat normal. When you look at that graph, it'd be pretty close to normal there. Inverse t of 0.95, comma, 47. And they got the same answer we did. If you use the table, you'd have to stop at 40. It doesn't even go up to 47, so it's getting pretty close to normal right there. So what are the conditions? The conditions are, these should look pretty familiar. A random, so random sample, if it's experiment, it'd be random assignment. Less than 10%, same as what we're used to. Instead of the, when it's means, the center limit theorem takes over. So we need a sample size of at least 30, or a graph that doesn't have strong skewness or outliers. It has to look somewhat symmetric. We're kind of loosey-goosey a little bit about that, but if it's smaller than n is smaller than 30, the graph has to be somewhat symmetric-ish and no strong skewness. Okay, so are the conditions met? When you get engaged, some people choose to buy a ring for their partner. How much do people spend? To find out, the New York Times and Morning Consult surveyed a random sample of 1,640 U.S. adults. This will actually be interesting. Find out who bought an engagement ring. So, I thought they might give us the number here. They didn't give us the interesting number. So, are the conditions met? So, it was a random sample. I like that, of U.S. adults who bought engagement rings. And that's hard to do, right? So, less than 10%. So let's see, 1,640 is less than 10% of all U.S. adults who have bought an engagement ring. That's true. And finally, is n at least 30 here? So 1,640 is greater than or equal to 30. So we don't have to draw the graph here because central limit theorem is taking care of us there. How much force does it take to pull wood apart on average? The stem plot shows the force in pounds required to pull apart a random sample of 20 pieces of Douglas fir. So we have a stem plot there. Okay. So is this a random sample? Clearly it says random sample. 20 is less than 10% of all pieces of Douglas fir. And then that is n at least 30. So it's not. So we need to look at the shape of the graph. And you can kind of tilt this stem plot over and you can see that that's skewed left here. So strongly skewed left, I would probably say even. So that does not pass the 3 conditions there. It passes 2 of the 3, it just doesn't pass the normal large sample condition. By the way, we call that the normal large sample instead of large counts. Okay. the AP Stats exam asks you to calculate a confidence interval. All the conditions should be met. However, you're still required to state the conditions and show evidence they are met, including a graph if the sample size is small and the data is not provided. So if n's less than 30, you should show the graph. That's what you need to do. What critical t-correct should you use for this one? So again, you're going to use your calculator. So 0.99, 79 for inverse t, and 0.995, 24 for the degrees of freedom for that one. Again, degrees of freedom is 1, n minus 1 basically for this type. How many hours do students at Lanier High School spend on extracurricular activities each week on average? To find out, the principal selected a random sample of 100 students from the 827 students at school. Are the conditions met? So seems to be a random sample. That's good. Oh, sorry, they checked them all there. So 100 students is less than 10% of the 827, right? No, it doesn't meet that conditions, does it? There's only 827 students at the school. This is not a large high school. It's not going to work, right? So they selected too large of a sample size. It is good that n is at least 30, but the second condition for it doesn't have independence there. Second part of that question, or another question, I guess. A local burrito shop. Oh, that sounds good. It's known for its large, delicious burritos. How many ounces, on average, do burritos at Rob Burritos weigh? During 1 month, the manager selected a random sample of burritos, weighed them before they were served. Here's a box plot of the data. So, okay, you got the box plot. Question is, are the conditions met? So, random sample, yes, check. N is 61, so that's bigger than 30, that's good. And less than 10%, so is 61 less than 10% of all the burritos made during the month? Yeah, that seems fair. So, yeah, passes the condition. That's good. That's your lesson for today.